Well, good evening and welcome to Space Oddities. I hope everybody out there is okay. Lovely to see you. Thank you for joining us on this Tuesday evening. We're a bit ill here. I've got a terrible cold. Michael has got a most amazing cough that sounds like a walrus being tortured. If you're lucky, he might show that to you later.
A walrus being tortured sound.
Yes, Keith, quite right, says in space no one can hear you cough. That's very true, Keith. So there we are. So thank you for joining us. And first things first, of course, as always, thank you very much for those of you who are buying us coffees to help us keep the show rolling. I'm joined this evening by Roger in deepest, darkest, clearest Somerset.
Cloudy Sparkford.
Oh, it's not cloudy. Don't believe you. It's never cloudy in Scotland.
All right.
Daz, how's life with the Sea Star going?
Well, they're good for taking photographs of clouds. I've managed to get out. Last week we were talking about they've posted an update. Well, I've received the update because I was going to do a sort of bit of a report on it and just show how easy it is to use. But I've got to get used to the new update because there's a lot more features on there now.
Great.
Which make things even easier. So you can even do the stacking now on your phone. Straight through Deep Sky Stacker. Well, I'll have a quick chat about it a bit later on. So
okay. Yeah. Well, if you could put some sort of video together for us,
we'll sort something out,
setting it up or something like that, that'd be fantastic. Yeah. Also joined this evening, all the way from the US, by Mr. Lou Mayo. How are things, Lou?
Well, things are good over here, and I just want to say, lucky for Roger, it's been cloudy the last few nights. So I just want to. I still have not had a chance to play with the Sea Star that my university purchased, so I'll probably only get to use that every Thursday. We'll see.
My video appears to be doing weird things, and I've turned green.
Ooh.
Shrek! It's Shrek!
Yeah. Hang on 1 second. Sorry about this. We did have a technical hitch with me turning into Shrek. 1 second. Let me just sort this out.
Or is it Fiona?
Now you can't see me at all, which is probably even better. Hang on. No, it's not going to. Hang on. Just let me change the colour. Oh, gone. Oh, hang on.
Your alien disguise is coming off. That happens.
Yeah.
That's about it. That's weird.
Yeah. If you throw a bucket of water on me, you'll be, I'm melting. I'm melting.
I'm melting. Okay.
Keep them coming, guys. Keep them coming.
There we are. I'm back to.
Oh,
there we are.
All right.
No. Anyway, also joined this evening by Michael O'Thumb. There we are. How are you, Michael? How's the thumb?
Fine. It's just the throat that's the problem at the moment.
Yeah. So good luck with the thumb. Show us your thumb, Michael, so the viewers know what you're talking about. There we are. That's one hell of a thumb.
That is a plaster on the thumb, not the thumb itself.
Yeah.
Use your thumb there.
Yeah. So Michael is now a professional hitchhiker. So there we are. And
too true.
Sorry?
Too true.
Yeah, too true. Absolutely. And joined, last but not least, of course, by Mr. Keith Moseley. How are you, Keith?
Oh, fine, thank you. Still sending you terrible jokes.
Yeah, I know. We'll have to stop at some point. I don't think my head can take any more.
Well, I guess there is time for just one short one now.
Oh, no.
I'll leave it.
Go on.
Oh, all right then. Yeah, there we go. An athlete walks into a stadium carrying a long pole over his shoulder. A boy approaches him and asks, "Are you a pole vaulter?" He replied, "No, I am German, but how did you know my name?"
Oh, dear me.
Oh, dear me.
Moving on. Anyway, Keith is the star feature
That was a
tonight.
bit electric.
Keith's going to be telling us this evening, in the first of a new series, I believe, all about the wonderful science of astrometry, that is to say, the stars and their positions and their motions. So that's not something I know an awful lot about. So it'd be great to see that, Keith. So stay tuned for a brief rundown of astrometry this evening. What else have we got lined up for you? Lou's going to talk about Voyager 1, I believe. Yeah.
Yep. A sad story. Sad story.
Yeah. we know, but there we are. We've also got some news about our merchandise, but we'll go through this in order, first of all. So thank you for supporting us with your coffees. If you would like to buy us a coffee, all you need to do is scan the QR code there. Couldn't be simpler. And buy us a coffee. Your money does go directly towards keeping the channel running. And we'd like to obviously be with you on YouTube for as long as we possibly can. And there we are. So you can scan the QR code. As far as the merchandise goes, well, we've got the normal Space Oddities T-shirts. You have to buy them, viewers, because summer's approaching. You don't want to be without a Space Oddities T-shirt in the summer, do you? Obviously not. These are amazingly cheap T-shirts. They are £20, but they does include UK postage and packing. Please add £10 for foreign orders, and they are remarkably good quality. And you know, be the first kid on your block to have a Space Oddities T-shirt. We've also got the Space Oddities hoodie. This is available for £40. It comes in two designs: the slip over the head design with the logo on the front, and the zipper type with the design on the back. £40 again, including UK postage and packing. Please add £10 for foreign orders. But we're delighted to tell you we now have an addition to our merchandise this week. The Space Oddities lapel design T-shirt, 10 colours available, where the design and the YouTube address is on the lapel, as the name suggests. These are the same price as the other T-shirts. They are £20, including UK postage and packing. And if you want a long sleeve version of that, it will cost another £3, just £3. And so that, by my maths, that works out to £23, including, again, UK postage and packing. And there we are. So, and we will be adding, as summer approaches, we will be adding underwear and lingerie and all sorts of stuff to the size range. Michael will be modelling these. And as he is indeed,
T-shirt, Andy.
as he is indeed this evening modelling the new Space Oddities lapel design T-shirt, although he has got the long sleeve version because he's old and it's winter. He had to get the long sleeve version.
Old and cold.
Yes, and Michael's came with a free jar of Ovaltine. So there we are. Oh yes. So anyway, that's that. As regards Mr. Robin Edgar, who spoke to us, you may remember, about the influence of eclipses on ancient cultures. There was a fantastic response to that, so thank you for that. Everybody seemed to really enjoy that. I'm pleased to report that probably in a couple of weeks, Robin will be back talking about the depiction of eclipses on the famous Nazca lines in Peru. So we look forward to welcoming Robin Edgar back on the program soon to learn more about the depiction of eclipses in ancient cultures, which I'm sure he'll agree was very interesting indeed. Now, what we'll do first, I think before we come over to Roger, I just want to mention a couple of brief news items. And that is to say, I'm afraid I haven't had a chance to put a full news thing together. I've been up to my eyes in exams and reports, but now I've done all those, and I will do a full news column next week. One interesting story that came up this week was about the material from asteroid Bennu, which you may remember was brought back to Earth and touched down in the Utah desert. The problem they had, of course, if you remember, was that they couldn't get the container open to get at all the sample. Well, they've done that now. This is a picture of all of the material that was collected from asteroid Bennu, and they have come to a preliminary idea that this material originated in an ancient ocean world in the solar system, perhaps a bit like Europa or Enceladus, because they found some compounds in there which indicate that they came from a watery beginning. So that's interesting. We'll bring you a more detailed report on that next week, because I haven't really had a chance to delve into that in any detail yet. And I think Lou has kindly volunteered to talk about that next week. Mm-hmm. So we will we'll look into that for you. Very interesting. That's a very brief news story before we go over to Roger.
Well, just before I do that, Stuart in the chat,
Mm-hmm.
where he's referring to our T-shirt, says, "Could a sweatshirt be available at some point?" Well, watch this space. But Kevin Earp's come up with an answer. It says, "Buy a hoodie and cut the hood off." So
Practical as ever.
so, okay then. Yeah, I've just got a couple of little news items. Let me just find me. Excuse me. Well, I just right. First of all, I don't know if anyone saw this today. I only sort of came across it today. I don't know whether it actually broke today. But does anybody know what this is?
It's the sun.
And Demos.
Curiosity eclipse.
You're close, Keith, but it's not Demos.
Phobos.
It's Phobos. Yeah, it's one of two. One of two. Yes, if anybody's ever wondered what a eclipse looks like from Mars, well, here you go. This is Phobos crossing the sun, and it was this was the. Let me just move this forward. So it's the moon Phobos eclipsing the sun as seen from the Martian surface. The images were captured by Perseverance sat in the Jezero crater on the 8th of February 2024. So I just thought I'd pop that in. That came in today. These green dots and all that. I mean, I think the orange ones are campfires on the sun, and the green ones are foliage. So no, I think these are just hot spots on the
cold pixels.
Pixels on the thing. So don't get excited about all these coloured spots and all that. But I just thought I'd like to pop that up there for anybody who's seen it. It's what an eclipse looks like on the Martian surface with Phobos going across the sun. I just thought I'd pop that out.
It's a shame it's not total, but obviously it will never be total because of the size of Phobos.
No, Phobos is far too small to be able to do that. But I just thought it looks like a bit of like a potato. But it's just if anybody was wondering, that came out today. I saw that today.
Kev says, should that be a transit? Eclipse?
Well, the transit. What is a transit? This transit is an eclipse. So it did dim this. It dimmed the sun. So in a way, it was.
It did dim the sun. Yeah.
The light actually dimmed.
Nice.
And so in a way, like I said, it's you can have it either way. You can either have a transit or an eclipse. It's up to you. It's I thought it was just amazing anyway, just to be able to see it. And there is actually I think it's space.com. They've actually got a video of it as well. It's quite spectacular. So that's the only thing I wanted to say about that.
Okay, can I just go back to Stuart's question about the sweatshirt? Just to give you a definitive, we are planning a sweatshirt, Stuart, and we're also planning baseball caps, and for those that like baseball caps, and a few other things. So we will be expanding our range of merchandise towards the summer. So keep your eyes open for that. And thank you for your inquiry. Okay, right. So, I think it's about time we gave let Roger off the leash now, isn't it? I mean, what's up in the sky, Roger?
Well, clouds mostly, unfortunately. But here we go for the 13th to the 19th of February. And as we progress through the week, we've got the first quarter through up to the weekend and onwards through to its conclusion of the full moon. But this is what it looked like last night when I had some clear skies, looking rather gorgeous. And there was there was rather a lot of earth shine on there last night, but obviously I didn't catch it with this image, but it did look rather amazing.
Very nice.
Okay, so here we go for the sky through the week, and Jupiter still in the sky at a reasonable height, with Orion now past the meridian, and galaxy season is coming up with Leo and Virgo following behind. But we don't have anything else to report planetary-wise because Saturn is now long gone. And we do have, as we can see here, a close approach of the moon on the 16th with the Pleiades. So that could be a good opportunity for anyone who wishes to take a photo, should they have a gap in the sky. Good luck with that. But in the morning, we've got Mars and Venus getting closer together in the morning sky. That will culminate in a conjunction on the 22nd. So still got a week before that happens, but a good opportunity to once again see a small dim Mars if you've got a good set of eyes and a clear low horizon before sunrise. So there, as we can see on the 20th there, they aren't too far apart at all. And if you're still following the comets, Pons Brooks is now going through Lacerta, and it's as you can see, it's still brightening up for a possible naked eye visibility in April. So fingers crossed for that.
Yep.
And Comet Kushida is now passing through the back end of Taurus now, and that is well dimmer than the other comet. So there we go. Okay, on to the exciting part. We have a good gallery this week. First one is from Keith Moseley of a solar close-up. And we will...
Oh, wow.
Look at that.
Yeah.
That's really good. That's amazing.
That's lovely.
Got some nice details there of all different sorts of things. Filaments and prominences and spots.
Yeah.
All sorts there.
Did
Very nice.
you say what telescope he used to get that image?
It was a Starwave AT with a quark.
Okay. Nice.
Very nice.
There we are.
Well done.
Very nice. Well done. And we've got a few from Kevin. We've got a trio of images from Kevin. The first one is the Cone Nebula. That was
look at that.
just a few days ago, yeah. So we've got the Cone Nebula and what they call the Fox Fir Nebula, which is above it.
Oh, yeah.
Yeah. Absolutely beautiful. Great. Well done.
Very good.
That's amazing.
2 3/4 hours as well.
Wow, that's not bad, is it?
Not bad at all.
That's not bad at all. No. He's used Pro L Enhance for that.
Wow.
So that's obvious. And we've got a horse head.
We always like seeing the horse head.
We always see the horse head, and that's
48 times 5 minutes. Yeah.
Oh, wow.
That is amazing. Look at that.
Very good. Yeah, and that's with the Edge HD 8-inch.
Wow.
Sorry.
A lot of detail.
Very nice.
Well done. Love that one.
And the final of Kevin's trilogy is the Owl Nebula.
Twit-woo.
Twit-woo.
Oh, yeah.
Oh, look at that.
Yes.
Lovely colour, isn't it?
It is
very
beautiful.
nice. Very nice.
You can see why they're called planetary nebulae, can't you?
Very nice.
Really nice.
Yeah.
Okay. Right. And another regular contribution from Jerry with the M78 in Orion. And this is with his Ritchie Crichton 6-inch telescope.
Oh. Look at the colour.
Yeah.
Yeah.
Amazing.
Very good. Well done, Jerry. Very nice.
Congratulations, Jerry.
And all we're surrounded by all that gas illuminating.
Right.
Yeah.
So we've got a sea star image from Sonia of the Sun, and we've got a collection of some of the sunspot groups there. Very nice.
Yeah, you can actually. Can I just pop in here? This is one of the updates that they've done. You can actually now zoom in. You've got sort of like *1, *2, and *4. So you can actually zoom in, as you can see, as Sonia's done with these sunspots and that.
Optical zooming?
Yeah, optical zooming. So you can actually zoom in and then take individual photographs of the sunspots. And there has been a big sunspot cluster moving across the sun this week, which has been very spectacular. I've only been able to capture it through thin clouds. So I think you can actually see on here, you can see there's some slightly dark grey bits, and I think Sonia's had the same problem, but not as bad as I have.
No.
And of course, she's gone for black and white, because sometimes black and white will bring out the definition better. But yeah, this is one of the upgrades they've done. You can actually zoom in on the sun photographs now.
Right. Steve says he thinks it's actually an electronic zoom.
A digital zoom, yeah.
Yeah.
Digital zoom.
Yeah. Thanks, Steve.
No. And this is what the sun like a few days ago from myself.
Yeah, there's a big grouping right in the centre.
Wow.
Right in the middle, yeah.
And this is the one that's been giving us lots of flares over the last few days. They culminated today. I was talking about it earlier. I did post earlier. It wasn't as big as we were hoping it was to be big, but there could have been some aurora in Scotland, Northern Ireland. I haven't seen anything posted yet. But it's been very, very. In fact, the sun has got several regions now that are really firing off. And if you look to the left limb, you can see a light area, and there's a little dot inside of it. This whole area has been firing off as it's come off the limb. So this could be another active region. It's going to give us fun over the next few days. And also there is a region just coming in from about sort of like the 10 o'clock region. And again, that's been firing off lots of flares. So it'll be interesting to see. It's getting very, very active again. And I have noticed that the sunspot count has started to rise again over the last 2-3 months. So
yeah, I mean, that main group consists of 36 spots.
Yeah, it's amazing. I managed to catch it, like I say, a hazy picture of it, but that's brilliant.
Okay, so here's one that I caught of Comet Kushida when it was getting near to Aldebaran on the 11th. It's not as bright as Pons Brooks, but I did manage to catch it. Unfortunately, the glow of the stars was because of the thin cloud that was giving that effect, but it came out.
Yeah, but also with that, like you say, that diffuse effect, you get more of the colour of the stars come through. So
you can see how the glare of Aldebaran is sort of overwhelming the picture there.
Yeah,
which is why I kept the exposures down a bit.
Yeah,
right.
That's fantastic.
And my last one is the jellyfish in Gemini, in SHO.
Oh wow,
that's fantastic, isn't it?
That's amazing.
I finished that last night and assembled it this morning, so sort of hot off the press, so to speak.
Yeah.
And this is the first time I've done this image, even in any form. So
absolutely
quite pleased with that. Although I did do it in HA last week, so I thought I'd finish it off with the other narrowband.
I mean, it always reminds me of a brain. This one. With the brain stem at the back. It's it's a beautiful picture. Very, very, very.
It's impressive color, Roger.
I like the green.
There you are, Lou. I've thrown the gauntlet down.
Roger, did you say how many hours it was?
Just 7 in total.
Oh, so about 15 minutes
and
for a sea star.
Only an hour and a quarter. Yeah, only an hour and a quarter with the hydrogen alpha.
Yeah, about 15 minutes with a sea star. Yeah. Okay.
Yeah. Right. We'll see if Lou can do it with the sea star then.
Not with the sea star. I won't live that long.
Yeah. Right. What we've got here. I don't know if you can see this. But let's make this big. Right. As you can see with the update, as I said, they've brought more features in, which actually are more on the phone. Means you can actually do more. Now, as you can see on the left, this is an image directly off of the sea star, and as you can see, I've already stacked it. One of the features they've brought in is they've now got a star stacker on the comes onto the phone, and you can actually take your images. You go to your gallery, which is stored actually on the sea star. And you can choose which images you want to do and stack, and you can actually do them on your phone. And then with a little bit of a Piggery Jokami on the phone itself. I haven't taken it into any processing apps or anything like this. It's all done on the phone. You can bring this sort of detail on the right out. So it's not, probably with more stacking and more images and all that, you could probably get a better definition. But it's just to show you something that you can actually do this. And this probably took about, 5-10 minutes to do the stacking. It's all done for you. It's all on the phone. And like I said, this is all with the update. So I'm still working through what they've actually changed.
That's a brilliant difference, though, isn't it?
Yeah,
it is. And this is, like I said, this is done on the phone. It's just the basic.
You got more definition in the one on the right. Definitely.
Yeah, it's just using what's on your phone. A bit of an editing tool, and that's it. So you imagine what you could do because you can also download this now onto your computer, and it can be what do they call it? What's the format, Rog?
Is it TIFF?
Not TIFF. Fits. That's it. You take down into fits, so you can manipulate it all the way. All the data's there.
Daz, when you brought this up, I was sure you were going to say the one on the right is a C-star image, and the one on the left is a Hubble image. That's where you're going.
I don't compare this to a James Webb. So.
Yeah. But looking at the one on the right, you can tell the difference with the red gas cloud past
and this, like I said, this is just brought out. It's not actually sort of like processing the image. All I've done is I've enhanced it. And for people who have never done anything like this before, it's just so simple. And as I said, once I've got my head around the new update, then I'll produce something. So I can't see what I'm going to test the simplicity of a sea star to destruction. I have no photographic skills or any knowledge. So okay then, right, I'll give it a go. I'll tell you what, they're very, very sturdy little. They're very sturdy little things they are. But yeah, I'll leave it there. I'll do a.
Good luck, Graham. Good luck. Can't wait to see the results.
Yeah, because I mean, I've been out with mine at -4. It still runs beautifully. It doesn't the batteries don't run down because it's cold. So if somebody says they can't even see the stacking, if you look on the left image and then look down the left edge, there's just a very thin line where you can see it's stacked.
Yeah.
So
Good luck, Graham. We'll be thinking of you. Yeah. All right. So thank you, Daz, for that.
That's all right. No problem.
I figured remove that.
Oh, sorry. I do apologise.
Just out of interest, we may be mad, but a few of us are getting up really early tomorrow morning to cover the launch of the Intuitive Machines Odysseus lander, as it's now been named, which is part of the NASA Commercial Lunar Services Program. And it's going to be heading to the moon to land some experiments on the moon on behalf of NASA. And liftoff is, the launch window opens at 5:57 UK time tomorrow morning. We'll be covering it for you live on Space Oddities. And Intuitive Machines have a good website you might want to look at. They say they open progress to the moon for the progress of humanity. It's launching on a Falcon 9 tomorrow morning. If you would like to join us, I know it's early, but we'll be there. 5:57 is the launch, and we'll probably go live here in the studio at about 5:30. Daz, is that too early for you?
Yeah, that's fine. That's fine.
Okay.
So
5:30 tomorrow morning here on Space Oddities. Join us for the launch of the Intuitive Machines lander. As we know, moon landers of late have not had good fortune, so we hope that this mission will be successful. And we'd love to have you sharing that moment with us when the Intuitive Machines Odysseus lander leaves for the moon. It's going to arrive at the moon on February the 22nd. So a few days yet, 8 days or so to get to the moon because of its trajectory. So please join us if you've got nothing better to do, or you're an insomniac, or whatever. We'd love to see you joining us tomorrow.
Yeah, and if you can't join us, buy us some coffees so that we can be wide awake. So
That's a capital idea, Daz.
yeah,
Absolutely.
buy us some coffee
Coffees
so that
are
we'll be
always
wide awake.
appreciated.
Yeah.
So we'll be live in the studio at 5:30 UK time tomorrow morning, and we look forward to seeing you. And that's it, really. So there we are. Right then. So moving on, we're going to go over to Keith now, and Keith has very kindly put together a series for us about astrometry. Before we do that, actually, Lou, do you briefly want to talk about Voyager?
I'll try if I can do it without sobbing.
Right. Okay.
This will take a little. So you all might have seen in the news that the Voyager 1 spacecraft has developed a bit of a glitch. And it appears that it's unable to send data back, although it looks like we can send information and commands to the spacecraft. So just to remind you, this is amazing. 1977, August and September. This is when Voyagers 1 and 2 were launched. I couldn't find enough pictures of this. I wanted to just throw up a ton of pictures. This was amazing. Launched on a Titan 3E. And this was the beginning of I think it's the longest robotic space mission on record. And in a few years, it will be 50 years since Voyagers 1 and 2 were launched, and they're still operating. Now, Voyager 1, we're not getting much back in terms of engineering or science data, but we can confirm that it is still operating. So, it was originally called MJS, Mariner, Jupiter, Saturn, only named Voyager after launch. And that's what happened with both Voyagers 1 and 2. Voyager 1's extended mission was sacrificed in order to get very close to Titan, which was a very interesting target. We knew that Titan had an atmosphere and with methane and all that. Voyager 2 went on to explore Uranus and Neptune encounter in 1989. And at that point, or shortly thereafter, they were handed over, these missions were handed over to the Heliophysics Division at NASA, and they became interstellar missions. So just a very quick overview of, let's see. There we go. So interstellar missions, here we see particle densities dropping off a cliff as Voyager 1 entered the heliopause and transitioned into true interstellar space, where the particle emissions fluxes they were gathering were not coming so much from the sun and the solar wind, but were coming from interstellar winds. They've only two anythings that have.
Sorry to interrupt, Lou. That is quite a rapid drop off, though, isn't it?
Mm.
It is. In theory, they believed, before they observed this, of course, that it would be a rather firm boundary. And it looks like that's in fact what they found.
Wow.
So 15 billion miles, 24 billion kilometers, and what is it, 47 years, I guess, and counting.
They were launched, incidentally, if anybody wants to place it in history, they were launched the same year that Elvis Presley died.
Yeah.
That gives you a sense. That's a good, the tough part is really communicating how old this spacecraft is and how old the technology is and how great it has performed. So, as we said, there is a glitch in the computer system. Voyager has 3 computer systems. It has a compute command system, a flight data system, and an attitude articulation and control system. This is the computer command system that was actually derived from Viking. The NASA budget was being cut back severely at the time in the 70s. We'd been to the moon, that was it. So they had to conserve budget where they could. And so they essentially took the Viking computer command system and used it for Voyager. It's a redundant system. It allows for single fault tolerance. The two CCSs can be operated independently or together. And it's responsible for managing the overall operations of the spacecraft, program sequencing, health monitoring, communication between the computers, and memory uploads. This was an 18-bit processor with a whopping 4 kilobits of memory.
Wow.
And could process 25,000 instructions per second. So that is the CCS. The second of the 3 computers on board is the Attitude Articulation and Control System, the AACS. This processor could process 30,000 instructions per second. And it is probably the case that for all 3 of these computers, they were programmed in Fortran 5 and assembler language. Those words are probably foreign to anyone who's watching us here, but quite, basically pretty old technology.
I've heard of those words.
That is still working for the most part. There we go. Okay. So the flight data system. This is where they believe the problem is right now. They're 99% sure that the problem is a flipped bit in the flight data system. You notice how old these pictures appear. So the FDS collects and formats and stores engineering and science data. Okay. And it can either transmit data, engineering, housekeeping, or science data in real time, or store it on magnetic tape. No kidding. This is a 16-bit processor with 8 kilobits of memory that can process about 80,000 instructions per second. Now, for comparison, this is about as fast as a Nintendo game back in the 1970s could process. Okay, so this was state of the art in the 1970s. It was the first spacecraft, the first FDS to use volatile memory, and the belief is that this memory got corrupted. A bit got flipped. Maybe it was a cosmic ray that came through, and it has messed with their frame sequencing. And so the FDS is now sending repeating patterns of 1s and 0s back to mission control at JPL. So it's affecting Voyager's ability to send back telemetry, but they're getting carrier waves coming back that are fluctuating, and they believe then that the packages they're sending up are being received, and that Voyager is still taking data. It just can't communicate it. Susan Dodd is the Voyager project manager. She was made project manager back in 89 or 90, I guess, when Voyager transitioned to a heliophysics interstellar mission. And to quote her, she said it would be the biggest miracle if we get it back. Although we certainly haven't given up. And I have seen the Voyager ground teams perform biggest miracles all through the mission to correct scan platform and other instrument problems and this and that. So I'm not giving up either. This is a redundant system. Yeah, there was another FDS on board, but it failed back in 1981. So they've been operating all this time with one flight data system, which is just incredible. Yeah. So I will keep you all updated on this. This is it's sad, but it's an enormous success story. These missions have performed for so long and sent back so much good data, and I'll keep you up to date.
Thank you, Lou. Thank you.
I think that the Voyager program was probably the most, amazing program of our time.
Yeah.
Of any time.
Yeah.
Anytime. Yeah.
This rivals the invention of fire, I believe.
Yeah. Derek says, what's the current time delay to Voyager 1? Do you know?
Well, let's see. It's out at about 50 AU, something like that, 8 1/3 minutes per AU. So you do the math on that, and you'll get a one-way light time. And they are receding at about 3 AU per year.
All right.
So you can add about a half hour per year to that.
Wow.
And am I right in saying that Voyager 2 was launched before Voyager 1?
Yes.
Yeah, that's right. Yeah.
That's right.
Yeah.
He wanted them to arrive at Jupiter in sequential order.
Yes.
And so Voyager 1 actually arrived earlier, but was launched second.
Yeah, absolutely. And also the another amazing thing, I think I'm right in saying that if you collected all the energy that is received from one of the two Voyagers, if you collected it, I can't remember the exact figure, but it's something like if you collected it for 1,000 years, it would be enough to light a Christmas tree bulb for a 250th of a second, or something ridiculous like that. But the amazing thing was how they enlarged the antennas of the Deep Space Network so that they could continue to receive and transmit to and from the Voyagers.
And another amazing thing is, yes, you got the 1970s technology with the Voyager computer system. Just think of what the ground controllers had to work with to download all that data and process it and produce the images that they got for us. You know.
And today, let's think about what the ground system crews have to deal with.
Yeah.
They have a 50-year-old, roughly, spacecraft.
Yeah.
Much of the documentation on the flight data system and other parts of the spacecraft are paper copies where they have to do archaeological digs, programmed in Fortran 5 and assembler. And many of the people who started out with this, many of my colleagues who worked on the Voyager infrared instrument along with me, have retired or passed away.
Yeah.
So, you know, it's remarkable what these ground system staff have done with the spacecraft so far.
Yeah, definitely.
And of course, when they've had problems in the past with the computers, they got to bring people out of retirement because of these systems they use. The youngsters today haven't used these systems, so they drag them out of retirement, and they come together and they fix it as best as they can. Fantastic.
I nursed that infrared instrument, the IRIS, the infrared interferometer spectrometer, for many years, calibrating and taking care of alignment problems in the optics and that kind of thing. So those kinds of instruments, the UV spectrometer, the imagers, the infrared spectrometer, they were turned off after Neptune encounter because they were just of no use anymore. But I have a great affinity for this little spacecraft.
Oh yeah.
Well, I think you know, everybody watching, including ourselves, Lou, would like to say thank you for all that you did helping the spacecraft operational.
They're still operational. So they're still in contact. If anybody ever wants to see the Deep Space Network talking to all these interplanetary the Voyagers and everything else that's out there going wherever it's going, just tap in Deep Space Network, and then you'll get all the telescopes, the radio telescopes, and you'll see who they're actually talking to at the time. So it's absolutely fascinating.
At AGU and DPS meetings, maybe at AAS too, American Geophysical Union Division for Planetary Sciences, American Astronomical Society, JPL brings a I don't know how tall it is. It's a 3-4 foot tall piece of equipment, kind of a cylinder, and it has individual lights on it, all up and down the column, and it's monitoring what data is being sent to the out from the Deep Space Network to spacecraft, and what data is being received. And it does that by spelling out the name of the spacecraft in little lights that flow up the column or flow down the column if it's receiving. It's pretty cool.
Sounds like it. Lou, if you ever want to do a history of the DSN for us, that might be an interesting topic to cover.
And the DSN is currently talking to the Juno spacecraft at Jupiter.
Is it?
With a round trip light time of 1.43 hours.
Fantastic. So yes, just Google DSN or Deep Space Network viewers, and you'll find it, and you can actually watch the antennas talking to the spacecraft and receiving from them in real time. It's quite fascinating. All right, so
25 hours. Sorry, one-way light time. 24 hours.
25 hours, right?
Sorry.
Thank you. 25 light hours away. Okay, so it's not much, is it? But it's a lot in human terms. So there we are. It's the most we're going to see for a while. So there we are. Our furthest spacecraft is 25 light hours away. So just over a day, a light day away. Yeah. So absolutely amazing. So let's get back to Keith. So Keith, are you ready?
Yeah, I've uploaded it. I think you've got it.
Don't see it.
Oh.
Should we try again?
Did you press
the present button?
Present button, yeah.
Hang on then.
If you go back into your sharing.
Hang on a minute.
Just bear with us for a second. Derek says, how long before Voyager 1 comes back as Vija? So let's hope it never does, because all it'll have to greet it is crap science fiction actors.
Yeah.
Let's hope it never does. Yeah. I wouldn't put it through that. So thanks, Derek.
Right. Should be ready now.
Yeah, and that was Voyager 6 anyway.
Okay, it's there. Right, so I'd like to introduce our speaker for this evening, Mr. Keith Moseley, who's going to be talking to us about the fascinating science of astrometry. So, Keith, the floor is yours.
Well, thanks very much. Actually, that it started appearing around about the wouldn't be, and in fact, actually, I used to live out in Pembrokeshire, in West Wales, and there's a beach there called Newgale Sands, and it has a big shingle beach at the back. And if you stand at the top of the shingle beach, you can see an island called Grassholm in the distance. And if you walk to the bottom of the shingle beach, it disappears, simply because it's disappeared below the horizon. Proof, if you want, that the Earth is indeed curved. And of course, people circumnavigated the world. The Chinese may have done it earlier, but the ancient Greek, because the Earth's very bright. Probably the story of this man is well known to a lot of you, so I won't spend too much time on it. But he attended in Alexandria, and he also knew that the sun at the same time would be shining straight down a well in Syene, which is now Aswan. And by the way, that well is big. I saw a picture of it in National Geographic at Alexandria. These would have used. You can see you get fairly realistic. I'll say I've reverse engineered it in a sense by using Google Earth to get. So his actual measurements were as accurate as the one that I've just done, because he didn't have Google Earth, of course. But he did get a circumference of the Earth to nearly 47,000 kilometers, and that's about 16% on the big side. But that's not bad at all, is it? I mean, when you consider the methods that were available at the time. Right, okay. But believe it or not, there's someone even cleverer than him, Al-Biruni. And whereas most people have heard of Eratosthenes, they may not. And first of all, you need to stand on a mountain top. So what he did was he found a mountain he could stand on, and measured its height, also using trigonometry.